Sarah, this is an expected value question. So the way we do this is we're going to take let me fix some things here. We're going to take the cost that it takes to play. Okay, so and then multiply that by the probability, essentially, of losing. So if 1,000 tickets are sold, I've got 999 out of 1,000. So as a percentage, 0.999 chance of losing, and that means I will lose $5 each one of those times. I'm then going to add to that the probability of winning. So if I win, it'd be 0.001, because one ticket out of 1,000, and then multiply that by 377, because that's the profit that I would make, essentially, or the value that I would attain. And we multiply that out, so let's see here, 0.999 times -5 plus then 0.001 times 377 gives me -4.618. So there you're seeing the 6.2. So again, that's an expected value question. That last question, I was just doing some searching here, is from section 4.2. And this question here is from 4.3. This is a binomial distribution question. And we can do this a couple different ways in regards to whether we do it by hand or use our technology. But the reason this is binomial distribution, there's a fixed number of trials, n is 12. There are two outcomes. The two outcomes are either left-handed or right-handed, so that's why it's binomial. So the probability of a success, okay, which we in the formula call lowercase p, is 0.15, because we want a left-hander. So then the probability of a failure, which in the formula we call lowercase q, is the complement of that, so 0.85. And then x, so this is a discrete random variable, and the number that x is going to take on, we're interested in it being 5. So when we say what's the probability of 5, the formula for this is n factorial over n minus x factorial times x factorial times p to the x times q to the n minus x. So once we type all that into Desmos, get that all there, you see our n minus x, here's p raised to the x, here's q raised to the n minus x, and we get that 0.019. If you want to use Excel, it's obviously a little bit easier in Excel. We'll just hit binom dist, I believe, is the command. So let's see here. Equals binom dist. And then it asks, okay, number of S, so that's the number of successes. We're looking for 5. Number of trials, we're doing 12. The probability of S is 0.15. And yes, we want cumulative, I believe. Nope, we must want. So cumulative, what that would mean is that's the probability. You saw it was like 0.99. What that would mean is probability of getting 0, and then probability of getting 1, and then 2, and then 3, and then 4, and then 5, and then adding all those up. So we actually want this, I think, to say false. Yeah. Okay, so false is what we're looking for there. I don't know if Desmos has a binomial distribution. Let's see. It does. So I can type in binomial dist, trials, we're going to do 12, successes of 0.15, and then if I hit find cumulative probabilities, I just want, I don't know if I go from 5 to 5, yeah, okay, so 5 to 5, so it's not cumulative, it just tells me the exact, if I want a cumulative, I'd go like 0 to 5 or 2 to 5, whatever. If I want just the probability of just 5 on the dot, but my min is 5 and my max is 5 and 0.019. Hopefully that helps. Let me know if you need anything else.